So welcome to today's webinar. My name is Matthew McKnight. I'm a technical specialist at Autodesk. I work from our Melbourne office. And today's webinar is a large assembly management with Autodesk Inventor. This is the part 2 of the presentation, which we started about 2 weeks ago. In the part 1 session, we looked at a range of different topics. We actually defined what a large assembly is and outlined some of the terms and considerations. We looked at some of the more common practices that may impact working with large assemblies and the performance of them. We talked about project planning and file management, how to set up the preferences and settings inside of Inventor to get the most of it. We talked about visual effects and graphics, as well as we started looking at workflows including express mode and large assembly modeling workflows. And it was at this webinar in creating this webinar that I realized the content that I was creating was much bigger than just the one webinar series. And so what I did is I actually broke the webinar up into 2 parts, and today we'll be covering a large portion of the topics that you see here, including assembly selection filters and how you can manage component count right through to system hardware when working with large assemblies. Now, the one thing that I was hoping to include in this session is to give you an example, a working example of working with a large assembly. The challenge is that there's still a lot of content to cover in today's session. I think we're looking at about 100. There are about 100 slides, which we'll go through in reasonably quickly. But having said that, that will leave little/no time for us to sit down and in any great level of detail go through a workflow of using a lot of the techniques and principles. So what I've done is I've scratched this aspect of today's webinar, and what we'll do is we'll follow this up in a specific webinar that'll take all of the things that we've done and just jump straight into Inventor and work with large assemblies to show you some of the workflows that we've been talking about over the previous 2 segments of this webinar series. So with that in mind, let's get stuck straight into the content and start by talking a little bit about how you can use assembly selection filters to improve your performance when working with inside of Inventor. So here's some tips on how you can use the assembly selection filters to improve your performance. For those of you who don't know where you can find the assembly selection filters, they're actually found in the quick access toolbar, which is across the top of the screen. So you'll find it about sort of 1/2 to 2/3 of the way across there, a little icon. When you click the down arrow beside it, you'll get a range of different selection filters. And these filters enable you to set the priority of your selection, things like component, part, body, feature, faces, sketches, and the likes, right down to some highly intelligent selection filters that enable you to be able to select components based on things like component size. Maybe you're looking to find all of the components that are less than 50 millimeters in length and suppress all of those, which can come in really handy if you've got say a 10,000 part assembly and you're just wanting to quickly define a representation that doesn't have all of those components in it. Maybe you're wanting to create a representation that defines a specific area of an assembly that you want to work in. Well, you can do that using the sphere offset tool as well. Or maybe you're wanting to simplify a design by removing a lot of the internal components inside of there, where you can use the select internal components selection filter. So the selection filters can be found in this way. There's also a shortcut of finding the selection filters, which is to hold down your Shift key and then right-click on your mouse, and then this will actually bring up the selection filters in the graphics window. So hold Shift key, right mouse button, and this should bring up a selection, a palette of selection filters that you see here on the screen. How can you manage component count, which is another critical aspect of when working with large assemblies? So this is really critical when it comes to working with purchased or standard components, is considering not placing hardware in the first instance or only placing those instances that are actually required. You can possibly replace all instances with one instance and then use a quantity override in your bill of materials or your parts list to accurately depict the number of components in place. Where you do feel it's necessary to actually use components in your assembly, try and define them as a pattern rather than individual entities. And the other thing that you can do is actually reduce the visibility of components using representations, and we'll talk about representations next. But each way of defining these, or just understand the consequence of defining all of your components as opposed to defining them using some of the techniques that we've outlined just here. Like we said, representations is another way that you can help manage large assemblies, and typically there's three types of representations. There's view representations, positional representations, and then there are level of detail representations. The reality is that view and level of detail representations are the ones that you can leverage to help you improve your large assembly performance. Let's start out by looking at view representations first. And view reps, which is what they're often commonly referred to as, store components' current state when the view is created, edited, and then saved. Okay, so changes to visibility and transparency and sketch visibility and work feature visibility, selection status, camera state, magnification, all of these sorts of things can be captured as part of a view rep. And view representations load a component only once. What this means is that if you open assembly with a large assembly with a specific view representation, it's only going to load the components that are required to show that view representation. Recognize, however, though, when you change view reps, so if I change from one view rep to another, it might add some parts and remove others, but the components that are being removed from the view rep aren't necessarily removed from system memory. So just recognize that. The good thing is that view reps improve both assembly performance and your capacity to open large assemblies as well and work with large assemblies. The way that you can create view reps is inside an assembly in the model browser. You can expand the representations folder, and then if you right click on the view there, you'll get an option to create a new view rep. Once you've done this, you can slow click on it to rename it, and then you can hide or modify components as part of that scene. At the end of this process, you do need to save it, and that save process actually captures the state that will be preserved at that point in time. And remembering, you can also use the selection filters as well from the quick access toolbar or from the shift and right click commands to help you quickly and easily create view reps. The good thing is you can create as many of them as you like, so you're not limited in the number of these you can create. But remember that whenever a component is made visible, it's loaded into memory. So if you've got numerous view reps and you're switching between them, recognize that each time you switch between the view rep, it's loading all of the components into memory, and they will stay in memory even if you switch to another view rep. The way that you can unload unnecessary components is to close the document and then reopen it with a specific view representation in mind. And you can do that from the open dialog by just going to the options, selecting the design view representation that you want to use, and then clicking OK and then open, and that will actually open that specific design view. Now the other representation we want to talk about is level of detail, or LODs. These are in some ways similar to design views, but in other ways different. So it's a view where, again, non-essential components, in this case, are suppressed, and an LOD does not load suppressed components into memory. Now the reality is that level of detail, or LODs, came about with the inside of Inventor due to the limitations associated with 32-bit computer architecture. So at the time, it was the best way of working with large assemblies and managing your memory usage of your system. But the reality is that the 64-bit systems now offer much more capabilities and capacity in terms of memory usage. And with Inventor stopping releasing a 32-bit version of Inventor, with Autodesk stopping releasing a 32-bit version of Inventor since 2016, there's, in some ways, LODs have come less of a critical part of the workflow when working on large assemblies. So when should and shouldn't you use level of detail in your designs? Well, you shouldn't use them when you have to switch lots between different display states. So if you're wanting to move from one representation to another, the requirement of an LOD means that it's unloading all of the components and then reloading the ones that are required, which is great because you're actually, at any point in time, you're not loading and maintaining all of the components previously like you would have a design representation or a view rep. But the problem is the process associated with unloading and loading means that it takes times associated with transferring between one level of detail and the other. You can also use LODs to create a shrink-wrap substitute. We'll talk a little bit more about this later on. But shrink-wrap substitute files can be large, which can also impact performance. So that's a consideration to take into account. And we mentioned this in part 1 of this webinar, and that is if multiple level of details are used inside of a drawing, performance can suffer. And the reason being is that when you open a drawing that's got multiple level of details, in essence it's opening multiple assemblies in the background into memory that it's managing when you're working on those drawings, which is not the case for view reps. So what we would recommend is that use one level of detail in a drawing, which will help you manage your memory usage on large assemblies. So when should you consider using them? Well, you should use them when you're working with reduced memory. Maybe it's because you don't actually have any memory, not much memory to begin with, or maybe your system's running low on memory. Then level of detail representations can help then. Also, when you're trying to remove intellectual property from a model that's going to be shared, it's a great way of doing that. And when creating a configured family of parts where components are suppressed based on the configuration, another good reason to use level of detail representations. So again, how do you create LODs? Very similar to creating a new view rep. You, inside of an open assembly, you expand the representations folder. You should see a level of detail. Inside of here, you can right-click that and say new level of detail, which will insert a new level of detail at the bottom of that list. You can slow-click that list and then rename it to whatever you want to call it. You can then move through and suppress all non-essential components within inside of that assembly, which are completely hidden from sight. And again, you can use the selection filters to help speed up that process as well. Remembering at the end of that process, you also need to save the assembly file to preserve the representation that you've created. A couple more notes on LODs, and you can also use an LOD, a shrink-wrap substitute, and these are discussed a little bit further down, and we'll go through those. But you can also convert a view rep into a level of detail. So you can see here on the image on the right-hand side, if you right-click a view representation, you can actually convert that to a level of detail. Which is a nice and quick way of converting some of those view reps into LODs when you feel as though you need to do that. Okay, so simplifying components is another way of speeding up or improving your performance when working on large assemblies with inside of Inventor. It's really a key step or part of the process in reducing the number and the complexity of components in large assemblies. What we would recommend is if you can find ways of reducing the number or the complexity of purchase parts or standard company parts that are used across projects, then simplifying those is a great path to improving your performance. You can also use the Shrinkwrap and Simplification Tools to simplify your model as well. So there are a couple of avenues for simplifying your designs. Let's talk in more detail about Shrinkwrap and Shrinkwrap Substitutes. So the Shrinkwrap process in essence really is just simplifying an assembly down to a single component. And this helps improve your capacity for managing and working with large assemblies, but also the performance of your system, whether using that design or any other downstream assemblies or applications. Shrinkwrap supports the use of view and LOD representations as an input to the result. And you'll also note that Shrinkwrap files can be directly referenced as an alternative to the parent assembly for drawings, distribution to partners, and so on. So how do you create a Shrinkwrap file? You can, the first step you need to do is open an assembly that you want to shrink wrap. On the Assemble tab, underneath the Simplification panel, you'll find the Shrinkwrap icon. And this will open the dialog box, which has got 3 tabs associated to it. The first tab, we specify the representations to use. We remove parts, and we can remove those by size if need be. And we can choose, any views to include or exclude when it comes to selecting our components. On the Features tab, we can actually further simplify our designs by going through and choosing features such as small holes and pockets and fillets and chamfers that mightn't be essential in the detail of our design. We can specify, feature size or select a feature and use its size. We can detect features, but we can also preserve features. So if there are unique features that we want to maintain inside of that Shrinkwrap file, then we can actually maintain or preserve those features as well. And on the Create tab, we can then, this is the way that this is the section where we go about naming the part. So we're giving it a name. We'll choose a template that we can that the Shrinkwrap component can inherit properties from. We give it a location. We can define its BOM structure. We can even do a bunch of other different bits and pieces like rename components, fill all internal voids and the likes as well in this stage of the design, along with preview our final product. Once we hit OK, it actually generates the Shrinkwrap component and saves the component for us. One thing to note that the Shrinkwrap file can be much larger than its base model, but the benefit here is that it's a simplified single part. So when it comes to using the Shrinkwrap component, this can be done in the assembly to reduce the component count and complexity. And we use a similar process when we're actually going through and defining content for building content for downstream consumption from the architecture, engineering, construction industry. So if you're looking to, or if you've got people that are asking for BIM content, there are simplified processes that are similar to the process we've just shown. If you're looking for further information about that, do a search with inside of Inventor Help for about preparing an Inventor assembly as BIM content or Inventor to Revit family file RFA workflow. And you'll get a step-by-step process of how you can go about doing that. Now, Shrinkwrap Substitutes uses a similar workflow to create a Shrinkwrap model, but then it associates that result with the source assembly as an LOD, a light representation or substitute for the parent assembly. So there's the differentiation between the two. Furthermore, you'll find that underneath the Shrinkwrap icon from the pull-down menu, you'll find that there's some further simplification tools there that can help reduce the complexity of components and simplify by replacing complex shapes with simplified shapes such as rectangles and cylinders. These can do things like create and edit a simplified view representation. You can define a rectangle or cylindrical shape or an envelope that represents a much more complex shape. And you can also create a simplified part from the representation. So let's have a look at some additional practices to employ before we then move on to look at some of the hardware recommendations. So assembly joint and constraint relationships. So fully constraining components or grounded components that are not designed to move in your assembly is good, but the reality is that assembly constraints require the software to perform a calculation. And so when there are many constraints within inside of an assembly, or many parts, each of which have got many constraints, then this calculation can become significant. So one thing that you can do is try to avoid redundant constraints, and this can be done in a system option or an application options. We showed some of this in the last, or part 1 of our webinar, and that is with inside of application options, you go to the assembly tab, and you can turn on the option enable constraint redundancy analysis. Now it's important to remove this, remove the redundant constraints, then turn off this option afterwards. Another thing you can do is use a common constraint reference if possible, and this is common with inside of, say, the automotive industry, where you'll have an origin or a 000 reference point, and then suppliers will be actually supplying components relative to that position to save the need of actually adding, potentially thousands of constraints within inside of a large assembly. You can also use constrain symmetrical assemblies to the mid-planes or center axes, but also look to resolve relationship errors as they occur. So don't get in the habit of just ignoring relationship errors. If it's an error, try and fix it, because potentially that's adding additional system resources to try and look at that error and try and resolve it. How can you resolve relationship errors? Well, as we said, it's good practice to ensure that you're doing this as it happens. And if you're not, if you're not sure how a relationship error has occurred, one good process to use is actually what's called Design Doctor. Now the Design Doctor is available, accessible from the Quick Access toolbar. So once it recognizes there's a potential issue with a relationship, it will actually show a red cross across the top of the Quick Access toolbar, and on clicking it, will actually open up the Design Doctor, and this can help step through the process of finding, examining, and then treating each of those potential relationship errors that you have in your design. The most efficient way of resolving relationship errors is to, especially when working with large assembly, is to open each sub-assembly individually to resolve any potential relationship issues there are with inside of that sub-assembly, save it, then move back to the top level assembly, confirm whether that relationship is now resolved and whether there's any potentially reason to look at it further, and repeat that for any subsequent relationship errors that might exist. So it's a rinse and repeat process of moving through sub-assemblies and even potentially even sub-assemblies with inside of those to resolve the relationship error with inside those sub-assemblies before looking at the top level assembly. Another area or potential area is model error handling. This is around feature functionality type errors within inside of maybe a design, where we use Design Doctor to help us problem solve our assemblies. We actually use Sketch Doctor to help us problem solve issues with our parts. This can be things like missing references or constraint failures, which are some of the key reasons for performance issues with inside of Inventor. You'll find that if you are encountering an issue with, say, a sketch, you can right-click it, go down to Sketch Doctor, and that'll open up a similar panel as what you see inside of the Design Doctor, which will highlight any sketch issues, enable you to examine those and treat them to resolve the problem. Some other things you can do when working with large assemblies is try and minimize the amount of work geometry that you're actually using. So turn off the visibility of any unnecessary work planes, work features like planes, axes, and points. Now you can do this quite quickly from within inside of the View tab in Inventor. Under the Visibility panel, you'll notice you've got the Object Visibility icon there. If you use the pull-down menu, you'll note that the top feature there is All Work Features. That's one of the quickest and easiest ways of turning on or off all of the work features with inside of this inside of the large assembly. So rather than going through and individually selecting them, or potentially even going into, assemblies and sub-assemblies and actually hiding those planes individually, now this is probably the quickest and easiest way of actually doing that. Another thing, and we spoke a little bit about adaptivity, is to turn off adaptivity when you don't need it. I'm sorry, I think we spoke about this in part 1 of the webinar series. So adaptivity should be turned off whenever it's not actually being used, because in essence, when it's turned on, it's frequently checking for recomputation, which can go on to lead to performance-related issues. You can find components that have got adaptivity turned on. You'll notice that there's a little circular arrow beside the icon of components and subassemblies in our design. You can right-click those and turn off individually the adaptive nature of those designs, which will, in essence, turns off adaptivity for that individual component or subassembly. Some other things that you can do in relation to parts is, for standard parts that don't change, consider placing them in a project library folder. The good thing about this is the Inventor searches these parts in a different way than normal parts, so that can help improve the performance on a day-to-day basis when working with these. The other thing you can do is limit the complexity of purchase parts or library components to only what's needed for an accurate design. Can you use a space envelope? Are holes necessary? What size holes do we need to do? The locations, etc. And look to replace unnecessary detail in ways that can help improve performance. Here on the image on the right, you can actually see 2 unique ways of applying the detail of the mesh of both the walkway and the guard around the outside of this piece of machinery. Now, in one instance, the designer has actually gone through the process of modeling small sections of expanded mesh into the design, but not the entire length of that section. So this gives the indication that this is actually an expanded mesh platform or walkway, but without the overhead of actually having to maintain, potentially hundreds of thousands of holes in a short section of walkway. The other thing is, in the guard, you'll see there that though it actually looks like it's a modeled mesh again, the reality is this is handled through an image that's giving a texture to the geometry that actually allows for perforation in our sheets. So again, much better capacity for handling, or the system has much better capacity for handling these types of products rather than products that do have all of the holes and all of the details modeled in them. The other thing you can do is suppress large feature patterns. Consider using a bitmap texture like we saw in the earlier image, but also potentially remove certain features. So can you remove physical threads or fillets? Do you need gear teeth on your gears, or can they just be the profile extruded around? And another area that you can look to improve your designs is the engineer's notebook. Now, I'm not sure whether many people know about this, but when you right-click on, say, a component or a subassembly, you've got the ability to be able to create a note inside of that component or subassembly. This opens up what's called the engineer's notebook, which is like a pad where you can write down and capture design intent and information decisions. And in doing so, we'll actually insert an image of the design, plus allows you to insert additional images. Now, if you are using this, try to restrict the note try to restrict the use of notes, whilst at the same time minimizing the size of the images, or potentially even using images at all. The reality is, by putting a lot of images into this, screenshots, screen dumps, or research information that you're putting into there, this again increases the file size and the way that potentially the way that the file works when opening and using large assemblies. And another area, we touched a little bit about this in part 1 of the webinar, and that is drawings of large assemblies. So There's a couple of options and settings that are advised here, and this is one of them we're highlighting here, and that is the turning on enable background updates under the capacity performance inside of the drawing options. This is going to enable background updates of drawing views, which displays a raster drawing view for large assemblies and calculates a precise drawing views in the background as you work. So it's actually giving a simplified representation in form of a raster view whilst it actually calculates an accurate representation. Some other things that you can do is the way that you actually place views can be improved when working with a large assembly. So many of you might note that when you go to place a large view, that it can actually be a timely process. When you place a view of a large assembly, it can be a timely process. So one of the recommended workflows is actually to follow some guidelines here, because what's happening is we're trying to minimize the rendering of an image which is visible by making it invisible. So the way that you can do is close the assembly file that you're working on, and this will prevent the graphics from being loaded into memory. Inside your drawing, then you go to the Place Views tab, you go to the Create panel and the Base View, and inside of the dialog box that opens, you click Open, and you can open an existing assembly. Now before you do that, you remember you've got the Options icon down in the bottom of your Open dialog that enables you to choose the view representation or the level of detail potentially that you want to use specifically with inside of your design. So you can actually go through and pre-configure the view rep that you want to use. If you click Open, this will return you to the Drawing View dialog box where you can then go through and specify the properties and place that projected view, and then hit OK to close the drawing view. So in essence, this will help when placing drawing views of large assemblies by not necessarily having an assembly loaded in the background, and it's using a much faster, much more efficient process of placing those drawing views. And some other things, when creating a drawing of a top-level assembly, a level of detail representations are used to suppress any unneeded component or replace many parts in a single representation. We've highlighted this well, but remember the key here is to only use one level of detail per drawing, and the reason why we do that is to avoid Inventor loading multiple versions or multiple level of details in the background. This is going to lead to improved performance when working inside of that drawing environment. The other thing you can do is before starting the base view command, you can click the document tab of the respective model. So if you've got an assembly open that you want to actually place a view of, click the document tab of that respective model to activate that appropriate document. And this avoids calculating the base view preview for a different model. So it actually creates the base view that you're about to place based on the representation of that model that's currently loaded into memory. A few other bits and pieces that you can do here, so avoid or reduce the use of property overrides at the edge level. If you're using drawing styles that are unique for that drawing, you can purge any unused drawing styles. And some other things and recommendations are to try and, just general recommendations around drawings, is to try and keep your drawing files as small as possible by one, limiting the number of drawing views that you have on each specific sheet, but two, then limiting the number of sheets that you have for a drawing. And I know that this might be hard, and there's a lot of arguments that could be had against this, but the reality is try where possible to try and minimize those, because each drawing sheet and each drawing view adds to the overhead required of the system to be able to manage your file when working with large assemblies. So now we've finished up a lot of the best practices and so forth, let's look at some of the ways that your system hardware, the operating system and the network can influence large assembly performance. So here we're going to look at all of those three key areas: hardware, your operating system and the network. Try and understand how they're going to impact the performance of your use of Inventor with large assemblies. But the key here to recognize that there's no single solution that's going to help in all situations, and it's really about understanding the impact of your decisions on your design environment that is going to best prepare you for investing in the right hardware. So the first thing that you can do is find out potentially what you're using. So if you've got an existing system and you're encountering performance issues, potentially one of the first things you can do, or the best things you can do, is actually look at your own system properties and hardware configuration. Now, you can do this in a number of ways. You can go to your computer properties, where you right-click My Computer or This PC in Windows Explorer, and then click Properties, and that should open a dialog that shows you your processor, how much RAM you've got, what type of operating system, etc., etc. You can investigate also using the DirectX Diagnostics tool, and this is available from the Start menu. You just do a quick search for DX Diag, which is DirectX Diagnostic, and then press Enter, and that should open up a diagnostic tool that can give you similar information, but then some further information that's specific to the DirectX system. Another way of doing this is inside of Inventor is to open the diagnostics area. And this can be done under Application, Options, Hardware by clicking the diagnostics icon down there and hitting the OK button. This will actually give you some diagnostic information that can be used to help problem solve potential issues that you might be having as well. Now, once you've got that information, if you are having problems, you can always come back to some of the commonly accessed areas that we point people to when they're trying to define a new system and understand the minimum and recommended system requirements for using Inventor. I've put some short links here that you can go directly to them. If you do a Google search for them, you're more than likely going to find links to each of these yourself. Probably the two key ones here are system requirements, which, as I said, define to you the minimum and recommended configurations for hardware, as well as the certified graphics hardware page, which can actually give you not only a certified system, but a certified graphics associated with specific Autodesk products, including Inventor and others that are available. Now let's have a look at some of the influence of individual areas of this process on our performance when working with large assemblies. So you can gain some benefit from using multiple processes inside of Inventor, but the reality is that having a single processor can be more desirable than having potentially slower multiple processors. There is some specific functionality inside Inventor that does support multi-core technology, and I'll look at this in the next slide. But the wisest choice when it comes to selecting a CPU is to procure the fastest single CPU that your budget allows, and potentially, if your budget allows 4 dual CPUs, to try and buy or implement the 2 fastest dual CPUs that are available. Here is a quick snapshot of some of the supported operations and features inside of Inventor that do take into account multi-core processors. So when it comes to creating or computing a precise view or computing multiple views when you've got the Enable Background Update option on, which is an option we turned off earlier, then this will actually leverage multi-core processors. There's certain graphics functionality when it comes to zoom, pan and rotate, ray tracing, rendering, selection, generating the mesh. Likewise, when you're importing non-Inventor CAD files, so say you're importing translated files or third-party file formats, then this will typically use multi-core processors. The specific modeling commands, actually most geometry modeling commands, leverage multi-core. Mass property calculations and the freeform commands use multi-core processors, as well as some of the simplification and task scheduler tasks as well. So again, if you're using these a lot, and the argument is you're going to be using some of these on it, for a lot of the things that you do, they will leverage multi-core processors, which can gain some advantages. When it comes to motherboards, some general information here. Try to choose a motherboard that uses a chipset made by the same manufacturer. So when selecting a CPU, consider that the onboard memory cache is going to potentially impact the performance. And that comes down to the amount and the type of onboard cache that's available. Use a motherboard that uses the same chipset as the CPU that you're using. So if you're getting an Intel CPU, then use an Intel-based motherboard. If you're getting an AMD CPU, then use an AMD-based motherboard. And also recognize that chipsets outside of this can be used, but they potentially might have stability issues, and often this can be associated with the AGP interface. The other thing to do is, even though you may have bought the latest motherboard and CPU or the latest system for that matter, the reality is that the BIOS are regularly updated, and it's quite possible that it's already out of date by the time you've received either the hardware or the new machine. So one of the best things you can do is actually download and update your BIOS with the latest BIOS from the manufacturer's website. So it's one of the first things you should do. When it comes to graphics cards, it's recommended that you use a DirectX 11 graphics card with at least 2 gig of video RAM. More commonly, we find that Inventor users are using NVIDIA's Quadro or something like the AMD 5 Pro. And it's also good practice to keep your graphics drivers and the BIOS updated as well. So you can get information associated with those from the NVIDIA and the AMD web links that are available there. Likewise, if you've got a laptop with a mobile graphics card, you can get the latest drivers available from the vendor's website as well. But yeah, this will definitely play a big role, and the brands that are listed there are supported and certified by Autodesk to run Inventor, which is highly recommended. Hard disk drive configuration. When it comes to hard disks, there's a number of things we'll talk about over the next few slides. Firstly, hard drive read-write times can affect and quite often significantly impact the time required to open and save an assembly. As such, a solid-state drive or an SSD can have significant improvement in performance when working with large assemblies over traditional drives. So if you've got the budget, and I would like to think that that most people would have the budget, especially when they recognize the performance trade-off of using an SSD, then we would recommend that you do try and use SSDs where possible. How can you organize your hard drives? Well, typically there's 4 places where information is stored when using Inventor. There's the operating system, which is required to run Windows, which you're using to run Inventor. Then you have the application, which is the Inventor application that's running as well. Then you have the data location, which is where all your Inventor data files are located. Then you have a temp location. This is where things like your page file and undo and any temp files are located. Now, in an ideal situation, they're all on separate volumes, so on separate disks, where the temp is striped, and we'll talk a little bit about striping of drives shortly, but data is striped with fault tolerance. Okay, so they're the 2 recommendations. Try where possible to have those on individual volumes where the temp is striped and data is striped with fault tolerance. So let's investigate some of the reasons for doing this. Firstly, files located in your operating system and applications are accessed frequently. In the examples of this, when a program is started, the files are loaded once into memory. But files located in data and temp are read and written often while you work with inside of Inventor. So, for that reason, the greatest benefit comes from increasing the read and write access speed to data and temp by using faster hard drives, and that's why we're recommending to try and use SSDs and try and use specific volumes for these where possible. Another thing that you can do is always create the page file in a freshly formatted empty partition, and this is to try and avoid fragmentation of that file. And we'll talk about fragmentation a little bit later on. The tip here is to set the minimum and maximum values for your page file size as the same value. The question is always, what should the page file size be? Well, you should equate that to your RAM. So somewhere around 1 times to 1.5 times actual RAM size. So on my system, I think I've got 32 gigabytes. So realistically, I should be defining my initial size and my maximum size as 64 gigabytes in each of those two locations. A little bit more information on page files. So don't place multiple page files on different partitions on the same physical disk. So if you've got a physical disk that's got partitions, don't be placing page files on each of those partitions. Place them on different partitions or a physical disk than the operating system. So where possible, try not to have your page file located on the same partition or disk as your operating system. Avoid having a page file on the same drive as the system files, and avoid putting a page file on a fault-tolerant drive such as a mirrored RAID or a RAID 5 volume. So the reason being is that there's no need to actually have redundancy of these, so or fault tolerance. So the reality is by putting it on a mirrored volume or a RAID 5 volume, in essence, potentially we're adding or needing additional system resources to slow down the way that information is being treated when saved. And when it comes to fragmentation, this is closely linked to data access. So as you are working with files, they effectively become fragmented. They end up breaking files up and locating them across various different aspects of your data storage devices. So by separating the OS, your operating system, and applications, it's really just cosmetic and does not result in much difference in performance. So you're not going to see a significant enhancement in that instance. But putting the temp files on a separate partition ensures that they do not cause fragmentation to other files. And so again, another good reason for keeping your files on separate volumes. Set the page, as we've said before, set the minimum page file size to the same value as the maximum page file size, and this is somewhere around 1 to 1.5 times your RAM. And this will help increase the performance when paging to disk. And create the page file first on an empty partition, and this will help avoid fragmentation of this and remove the need to be able to delete and recreate it. When it comes to defragmenting your hard drives, try to keep your drive defragged. Can help result in an improved performance and open time of invented documents, especially when working with large assemblies. There are tools inside of Windows that can help you do that. I believe that we actually show how to do that in the next slide. So here it is. So if you go to Start, Programs, Accessories, System Tools, Disk Defragmenter, you will open up the tool that was shown in the previous screen that can go through and actually defragment your drives. If you haven't done this for a while, you probably find that they can be they might need defragmenting. If you're looking to defrag your Inventor files specifically rather than all of your hard drive, then you can actually do that using a Microsoft tool. It's by following the link on the screen there. If you download that file, then you run it, you'll find, or run a command line, you're able to then locate specific Inventor program modules that you want to defragment. You run the config/a ** command, and then this will actually show you or create a report that contains the files. And what you want to do is look out for files that are averaging more than 1.5 fragments per file and defrag those. And you can do that by typing in the config/s ** command, and that will actually go through the process of defragmenting the files inside of those folders and any subfolders that are contained within some. So that's if you want to defrag just the Inventor files, but if you want to defrag your whole hard drive, then just use the Windows tool under the accessories. Furthermore, if you're still encountering slow startup times after defragmenting your drive, there could be potentially an issue or a problem with your disk or some input device. One of the things you can do is work with your local IT department to try and benchmark your drive and understand what the potential could be. The other potential issue could be that it might be an input device, some sort of specialized device that you're using with Inventor. One of the first things you can do is try and uninstall that and just use a normal mouse. So you might be using, say, a 3D mouse. In the first instance, uninstall that, or potentially even update the driver associated with that input device to see whether it is having an impact on your overall system's performance. Some other things you can do is disk cleanup can help. The disk cleanup utility is a one-stop tool for removing any unwanted and unnecessary files. It is a Microsoft tool that comes installed with Windows. Again, if you go to Start, Programs, Accessories, System Tools, Disk option, this disk cleanup, that will open the disk cleanup utility. And that will go through and look at log files, temporary internet files and the likes, enabling you to clean out a lot of this clutter that might be just simply, slowing down your system and utilizing resources that you could otherwise be using elsewhere. Now, we've talked about your disk drives and your disk management. Let's talk briefly about RAM, or random access memory. The reality is the more RAM you have installed on your machine, the better. And where possible, use the fastest available RAM. When working on large assemblies, you really want to be using at least 24 gigabytes of RAM, and this is going to help you manage, say, a unique assembly count of around 1,000 parts. But the reality is that if you're using beyond that, then you really need to start looking at higher amounts of RAM availability. And so if you're looking around 7,000 unique parts, then RAM of around 64 gigabytes is probably going to be more applicable to your requirements. So keep that in mind if you are encountering issues and running out of memory and potentially having to use your page file or virtual memory. Then potentially by increasing your RAM that's available for Inventor to be able to utilize when working with large assemblies can significantly improve the performance of working on large assemblies. Now, physical RAM can also, or your random access memory can also get fragmented as well. And so it's similar to fragmentation that can happen to a hard disk where you're storing all of your data. The most common resolution to this problem is to simply restart your machine. If you're working on large assemblies, probably one of the best things you potentially do at very little cost / no cost is at the end of the day restart your machine or turn it off, and then when you come in the morning the following day to start it up, which will actually effectively wipe or defragment your physical memory and refresh your system, which potentially could be built up if you just left it running for the week or longer. One alternative is to use a RAM defragmentation utility, which I don't believe is available in Windows and would be a third-party provide technology. So some quick recommendations. So let's just look at these quickly, and these can help you improve the performance when setting up and defining your system. Ensure that the operating system and applications and temp and data reside on different physical disks at the least different partitions. Consider that the biggest performance gain is obtained in improving the speed with which data and temp are accessed. And as we said before, try and use RAID configurations, which is redundant array of inexpensive disks, or is often referred to as striping of volumes, and this can increase your performance. This is effectively where you combine multiple disks that are performing to speed up the process and also improve the redundancy of working with of your data. For temp, fault tolerance is not necessary, so you don't need to have striping with fault tolerance of your temp information. And fault tolerance is recommended for your data files that you're storing on your drives. Ensure that the application data or temp files are not encrypted or compressed. So by having an encrypted or compressed file means that each time you need to work with it, it needs extra processing time to be able to handle that file. And ensure that the hard disk controller is not the bottleneck. So potentially sometimes what you might find is that the hard disk controller, which is a part of your hardware, potentially could be a part of the process that's just slowing down the performance of your system. For example, here we're talking about with an IDE, it's faster to put one disk drive per channel as the master. If more than one hard disk is available, verify that data is on a partition of one disk and temp is on a partition of another disk as good practice, and we've mentioned that before. Also verify that enough space is available in all partitions. Now, if you recall back to our part 1 presentation, we made a change inside of the application options for Inventor's undo file size. I made that change on my system, and the next time I went to run Inventor, it actually said that I didn't have enough disk space because it was taking into account the requirement that the undo space had significantly increased from its default size, and I needed to then ensure that I had sufficient space for all of those. So make sure that you do have enough space across all of your partitions, and do not place multiple page files on different partitions on the same physical disk drive. So effectively you don't want to be writing to the same physical disk across different partitions. Another area you can look at is things like hardware conflicts. You can use the MS Info 32 to see if there are any conflicts. So inside of your system information, under System Summary, expand Hardware Resources, and you'll find Conflicts and Sharing. And this will list any conflicts that you might have. The best thing that you can do here is update the drivers, especially anything that's conflicting with your graphics card or a network card, and potentially that can help improve your performance as well. The other thing you can do is, whilst we're at it, is to update your drivers for other devices as well. So when it comes to your hard disk drive or the controllers, whether it's the CD drives, which are probably less common nowadays, your monitors, your graphics card, your sound card, all of those sorts of things that you're using, make sure that the drivers are kept up to date with those to try and help ensure that they're using the latest firmware and drivers that are available for them, and help minimize the chance that they're impacting the performance of working on large assemblies. Now, when it comes to Windows, themes and performance, then you'll find that Inventor 2018 supports, and just referring to the current version, supports 64-bit versions of all Windows 7, SP1, Windows 8.1 with a knowledge base update, and Windows 10. When it comes to using themes, which is more and more common nowadays, and visual effects, these may actually use system resources with little productivity enhancement or benefit. So where possible, try and consider whether you're using them or to actually minimize the use of them to try and reduce their potential impact on your system performance. Likewise, with antivirus software, what we do recommend is that you configure it to scan only executables and not every file that's opened. You can imagine if it's scanning every file, then potentially that's adding additional resource requirement and slowing down your system when it comes to working with large assemblies. So potentially just change your antivirus software to scan only the executables and not every file which is opened. Another thing you can do, and I think we sort of talked a little bit about this type of stuff in part 1, and that is to free up memory by turning off things like add-ins and services. You can go to your task manager and across to the services icon, you'll see a range of services. Now, the first thing to understand when making any change to this area of your system is make sure that you understand the consequences of stopping a service before you do so. The other thing to do is to make sure that you keep notes of any changes that you're making so that you can revert back to previous settings. But otherwise, services running on your machine can often equate to additional resources required and often waste those system resources. So potentially turning off specific services can help improve the performance of your system. As can minimizing the number of background applications that you've got running at any point in time. Do you need to have all of those opening at startup? Do you need to having all of these open at the same time? So potentially turning off any applications that you've got running that might be in the background. And when it comes to network environment, there's a number of things that we can highlight to help improve system performance here. First, and this is probably arguably going to have one of the biggest impacts, especially when working across a network, is to use Vault, Autodesk Vault. Whether it's Vault Basic or something up as high as Vault Professional. Having a document management system that copies files from a network location to your local machine can significantly improve the performance of working with assemblies large and small. In essence, what you're doing is you're getting the benefits working across a network of sharing information as part of a team and being able to access that information, all working from a common data source, but then getting the performance enhancement of working locally when you're actually opening and working on those files. The next thing that you can do is trying to segregate engineering data into its own LAN segment. So this can help increase stability and reduce unnecessary bandwidth of having other areas of the organization also sharing your LAN segment. But you can also allow the engineering team to run at a full duplex 1 gigabyte speed as well. So this can also help improve your performance. When it comes to some specifics around your network setup, in terms of switches, local engineering ports on switches to 1 gigabyte full duplex and disallow auto switching. And this will help provide a more predictable and stable network for Inventor users in a shared environment. Likewise with network cards, again, lock all network cards to 1 gigabyte full duplex and do not allow auto detecting. And again, for Inventor users in a shared environment, this is going to help improve the stability of their system. When it comes to the data server, if you're having potential issues in accessing information on your server, then upgrading the Inventor file data server to handle an anticipated peak load of the engineering department could include a faster CPU, increasing the memory allocation, or adding additional network cards. You can also check the number of hops that are required to actually access your data server. You can do this using the traceRT command from the DOS command, and this will actually give you the number of hops between the workstation and the Inventor file server. What you want to try and do is minimize this to no more than 2 hops between those 2 locations. As well as when it comes to the LAN segment, ensure that the Inventor file server is on the same LAN segment as the Inventor users, and this is going to help improve performance as well. Now you can look at or monitor your network usage, and this can be both the workstation clients and the Inventor file server to understand the resource requirement on both ends. What you should be looking at to do is to keep the overall network usage at 40% or less on the server. If you're seeing performance requirements or system requirements higher than 40%, then it's likely that you're going to find that your performance is going to suffer, and the chances of data loss increases as well. There's a number of things that you can do here. You can upgrade CPUs, the memory on the server, and possibly things like network cards and the LAN segments associated with it. And finally, monitor network usage. Inventor uses segment loading of files, which can cause issues when you work on files over the network. Another good reason for you to work locally, and the best way of doing that is using Vault. The example here is when you open an assembly file, whatever Inventor does is it begins loading the BREPs, which are an acronym for boundary representations of each file, and you can start editing some of those part files. But the problem is if the network fails and you try to save, but you cannot, This is because the complete file did not transfer locally. It's only partially transferred the information over. In this case, it would be necessary to revert to an older version of the file, and this is part of the reason why we recommend that you work on a local drive. And again, another reason for you to look at Autodesk Vault. So finally, some tips on how you can increase the capacity of system memory. Now, by increasing system memory, we're going to look at this in 4 key areas and look at a number of ways that you can do that across general, parts, assemblies, and drawings. So if we just start at how you can increase, in general, the capacity of your system memory, keep the modeling level of detail of purchased or library components to what is needed for accurate design. So try and use space envelopes, hole sizes and locations where appropriate, and adding unnecessary information such as textures, threads, coil features and fillets can flow on to impact the performance and capacity of your system. Close any unnecessary applications that you don't need. So you might have, say, Outlook and Chrome or something like that running in the background. Where possible, close them. Not only is it going to free up some system resources, it's probably actually going to make you more productive because you'll be less distracted by incoming emails and surfing the web looking at the latest news. And the other thing you can do, and we mentioned this in the part 1 of the webinar, is to unload any unnecessary add-ins before opening an assembly. So inside of Inventor, you've got your add-in manager. Look to those areas of your system that you don't use commonly to unload them or stop them from automatically loading when Inventor loads as well. Again, some further general ways to increase capacity of your system memory. Consider not placing hardware parts at all, or only place one instead of many. And if you need to have representations of them all, try and minimize the detail in them. What else can you do? You can try and use patterns where appropriate to try and minimize individual placement of those components. Make it a practice to purge all unused style definitions, and you can do this from the Manage tab, Styles and Standards panel Purge. And this is a process of purging any unused styles. And also use the selection commands to hide or suppress sets of components, and we've talked a couple of times about those in today's webinar. Some other things you can do: suppress large feature patterns on parts and consider using a bitmap texture in place of large feature patterns. And you can see this on the image to the upper right there, where we've actually got a solid piece of sheet metal, and the texture is actually applies as a texture rather than as cutouts or as a feature. So this can give a very similar look to the overall appearance of the design, but significantly cuts down on the processing time to generate that part. Reduce any unnecessary details of parts, so threads and gears and teeth and fillets and those sorts of things. Can they be removed? Are they necessary? As well as minimizing the usage of move bodies in a multi-body part can also have an impact on your designs. So when it comes to assemblies, only use enough assembly constraints to achieve the required component position or motion. Remember, we talked about, each additional constraint adds additional requirement on the system to solve or calculate it, so try and minimize those. Avoid redundancy where possible, and you've got the option to be able to, under application options, to turn on enable relationship redundancy analysis, but remember to turn it off once you're done. You can minimize the use of assembly features as well as another good way of freeing up system memory, but also use a common constraint reference if possible. And we talked about maybe using the origin as a means of placing and inserting all components to minimize the resources required to constrain your designs inside of your assemblies. Furthermore, in assemblies, you can use a common origin for static assemblies using skeletal modeling. We talked about that in part 1 of our session. You can constrain symmetrical assemblies to mid-planes or center axes. Look to locate and fix or suppress any constraint errors. And you can use the design doctor to try and help you isolate and resolve those issues. Use iMates to reduce overhead and enforce consistency, and use component patterns whenever possible. Again, in regards to assemblies, try to use design view representations of large assemblies to display only the components that are needed for current tasks. And design view representations are great if you've got various different design views or representations you want to use inside of a drawing. Is a good replacement for level of detail. Use level of detail, however, to substitute representations to replace the entire assembly with a single part file in the same assembly file. We talked about this before using the shrink-wrap workflow. And again, inside of assemblies, use level of detail representations to suppress components that are unnecessary for the current task. So this is really good when working inside of the assembly environment to try and minimize the amount of resources that your system's using. But an example of this is to open an assembly with all parts suppressed and then unsuppress the parts and the components where needed. And this can help remove or reduce the amount of memory in use. In this case, as components are added to an assembly, get in the habit of suppressing the components that are not necessary for constraining or locating new components as well. Furthermore, for assemblies, turn off the contact solver after performing a contact analysis. There is an icon in your toolbar for doing that. Whenever possible, turn off the visibility of coils and springs in an assembly file. There can be complex geometry to create, and if you've got lots of them, they add to the resources required to generate them. Turn off adaptive. We talked about this a little bit earlier in today's webinar. And consider using grip snap to position components accurately and then ground the component once it's in the actual position. And finally, how can you increase your system capacity when working with drawings? Well, the first thing you can do is to keep the size of drawing files as small as possible, and this comes about by minimizing the number of views on a sheet and potentially the number of sheets in a drawing. So where possible, try and only use 4 views per drawing page and try and use as many drawing sheets as possible. And we talked also last week, or in the last webinar, about using bitmaps as part of your templates or images that you're placing in them. Where possible, try and minimize the size of those by potentially removing the bit rate of them, but also potentially changing them to a solid color like black. And then finally, in the Drawing tab in Document Settings, set Always in Bitmap Resolution from the drop-down menu. This can help when working with shaded views by minimizing the resources required to actually generate that view, to replace it with a bitmap and use a low resolution bitmap in place. So, if you want some additional information, one link that I will point you in the direction of is an interesting discussion inside of the beta forums. You need to have signed up for beta access to be able to get access to this discussion. But it is a discussion about graphic cards and the impact that it can have on your system. To get access to this, just follow that short link that's on your screen. But remember, you will need to log in using an Autodesk ID and have beta access to be able to do this. If you don't have beta access, you can always request that as part of that process. So a quick summary. Today we've talked about a range of different techniques and workflows that can help improve your performance when working on large assemblies, from working with selection filters to trying to minimize component count, how you can simplify your designs, and additional practices that you can employ, right through to then talking a little bit about your system hardware and the impact that it has on large assemblies, and then some workflows that can help you increase the capacity of your system memory when working in general in the software, but also on parts, assemblies, and drawings. We've also pointed you through to some additional information. Now, as I pointed out at the start of this webinar, we will be following this webinar up, and the date hasn't been defined, but I imagine it'll be in the next couple of weeks, and you'll all be notified as attendees of this webinar, or if you've signed up previously but been unable to attend this webinar, you'll get notification of this pending webinar, which should be in a week or so's time, which will actually look at how we use Inventor, and we'll go through step by step with inside of Inventor, using a lot of the principles that we've learnt over the last 2 webinars. How can you find out some more information, or how can you access the latest information in the meantime? So if you're looking for more information, the Autodesk Knowledge Network is a great place to go if you're trying to understand some of the principles that we talked about today. Just go into the Autodesk Knowledge Network. You can filter it down to Inventor as the tool that you're wanting to find further information about, and then do some keyword searches that'll come up with a range of information and feedback relative to the things we've discussed today. The other thing you can do is a lot of the information that we're talking about today is available from the Knowledge Network. If you do a Google search for Inventor Large Assembly Management, it should actually take you to a number of best practices locations inside of Autodesk and documents that can highlight a lot of the things that we've been talking about, and in some cases goes into more detail about them as well. How can you contribute to Inventor and the updates? One thing you can do is contribute in the form of the idea station. So if you've got an idea about how Inventor could be improved, or you'd like to provide some feedback about certain functionality, please feel free to participate in the idea station by placing your idea up there and then voting on any other ideas that other people have come up with. The reason being is that the development team does look to this as a resource of coming up with new features and functionality that's released in future versions of Inventor. Something else you can do is get involved in the beta program. So the beta program is currently going through the 2019 release of Inventor 2019, looking at new features, new functions, new workflows, and allowing users to provide early feedback before the product's actually released that can actually influence the final design of Inventor. If you're wanting to access the latest version of Inventor, you can access that in a couple of ways. You can use the Autodesk desktop app, which typically runs down in your task pane, and that will show you any entitlements that you've got, plus any of your currently installed applications, plus any updates that are available to those applications. So get in the habit of going in there and checking regularly to see what new updates are available for the software that you've got installed, and simply click it and follow through the prompts, and you can update any of your locally installed applications. The other way that you can access these is going to your Autodesk account by logging in to the Autodesk website at manage.autodesk.com using your Autodesk ID, and you can find all of the latest installers plus updates available there for download as well. Otherwise, thank you for your time today. I appreciate it. Hopefully, there's been a lot of content that we've gone through. I think I've been talking for the better part of almost an hour and 20 minutes, so it has been a long presentation. So I really do appreciate you attending today's webinar. If you'd like some further information or you want to provide some feedback, and there was quite a lot of feedback that was provided after the first session. So again, if you've got some feedback to provide me or you've got some questions, feel free to reach out. My contact details there. Also recognize that our authorized resellers in the region, and you can find them by going to autodesk.com/resellers if you don't know who yours are, also have technical people that are here to answer your questions when working with large assembly products, as well as give you some guidance around Autodesk Inventor and the other manufacturing solutions that are available in Australia and New Zealand. Otherwise, thanks for your time today. I really appreciate it. It looks like it's a nice day outside in Melbourne today. I hope everyone gets a chance to enjoy a warm, sunny weekend, and hopefully we'll see you in a week or so's time for part 3 of this presentation. Bye for now.